All right, we've got the basics down of just limits in general. So now we're going to focus on infinite limits. All right, so here's our definition. Basically, I'm going to paraphrase this as we go through here. So suppose f is defined for all x near a. If f of x goes arbitrarily large, then we're going to say the limit as x approaches a of f of x equals infinity. All right. If f of x is negative and goes arbitrarily large, then arbitrarily, what a word, right? Then we're going to say the limit as x approaches a of f of x is equal to negative infinity. Here's the kicker for this. In both cases, the limit does not exist. I'm going to let that soak in here for just a second. When you take the limit as x approaches a, if it goes to infinity or negative infinity, then the limit technically does not exist. Now, we still write the answer, infinity or negative infinity, but if you have an infinite limit, then technically the limit does not exist because L does not equal some value, some specific numeric real number value. All right. If it goes to infinity, then the limit doesn't exist because it goes on and on forever. I'm not approaching anything specific. I'm approaching infinity. You still write your answer as infinity, but we just look at it just a little bit different. All right. Okay. Check this out. Here's example 1. We want to analyze the limit as x approaches 1 of x over x squared minus 1 squared, and the limit as x approaches negative 1 of x over x squared minus 1, that quantity squared, using this graph. Oops, it's down here farther. Let me bring it up. All right, using this graph is what we're going to be doing. Look at what's happening. All right, so my limit as I approach 1. Now remember, if we have a limit that approaches a number, I'm not saying 1 from the left, I'm not saying 1 from the right. I'm saying straight up 1. So my limit as x approaches 1. So as I approach from the left and as I approach from the right, what is my graph doing from both sides? It's going to infinity. Right? Okay. Because as I approach from the left and I approach from the right, that bad boy's going to infinity. By that same rationale, look at what's happening. As I'm approaching from the left and I'm approaching from the right to get into negative 1, negative infinity. Limits are the same no matter what it is we're talking about, right? If x is approaching 1, complete 1, then I have to approach from the left and the right. If it's the same thing, then that's my value. If I'm approaching from the left and the right, the same thing, that's my value. Now here's a tip for you. Oopsie daisy. A tip. This is an even exponent. So if you think back to your college algebra, pre-calculus, algebra 2, whatever day that was for you, your behavior around your asymptotes, because you have 2 asymptotes, right? Here we know that this is going to be x plus 1, x minus 1, and that is squared, which tells me that this is x plus 1 squared and x minus 1 squared. Anytime you have a factor that is squared, your asymptote, because that's in the denominator, that's squared, it says that the behavior is going to go together. That's just a little extra for you, you know? You're welcome. So that's just a little patterns, right? So the longer you do this stuff, the more patterns you see, and that's just a common pattern with a rational function. If your factor here is squared around that asymptote that you have, then you know that it's going to be going in that same direction. If it's not, then around that asymptote can be going in different directions. All right, so let's take a look at this next. Let's talk about one-sided limits. One-sided limits are literally the exact same thing that I'm looking at, right? I can have, oops, let me make this bigger. Let me pull this over here and make it to where you can see it better. So we're just looking, so here's our one-sided limit. If I am approaching f of x and I'm approaching from the right, this is a plus sign there. I'm approaching a from the right, so I'm coming in this way. And my graph goes up. Then as I approach from the right, I'm going to infinity. If I approach from the right and my graph goes down, that takes me to negative infinity. One-sided limit. The exact same one-sided limit that we had when it approached a value. We have the same one-sided limit. It can go here or it can go here. Right? If your denominator factor is squared, that makes a difference. Or if you have a whole, that makes a difference, right? All of these things, remember we talked in that prerequisite part, I need you to know basics of graphs. Here's part of those basics. Limits are looking at what you have and making that determination. It's not as analytical as some other things that we do, right? It's not plug in a formula, get the answer. It doesn't always happen that way. You could plug it into the formula because that's our first step, right? Get that answer, sweet, best day ever. You could also plug it in and not get that answer, and then you have to think through it and work through it. If you're going to infinity, because I'm looking at what's happening around these asymptotes, then we need to work with that. All right? Let's do one more definition here of what we're looking at. We want to find, speaking of asymptotes, we know that these are vertical asymptotes. We can use limits to determine if we have a vertical asymptote and the behavior associated with that vertical asymptote. All right, so if the limit as x approaches a of f of x is equal to either positive or negative infinity, and the limit as x approaches a from the right of f of x is equal to positive or negative infinity, or the limit as x approaches a from the left of my function is equal to positive or negative infinity, then the line x equals a is called a vertical asymptote. If you are approaching a specific value, so in this instance that variable is denoted by the letter a. If you're going toward a specific value and your limit goes to either positive or negative infinity, that's a vertical asymptote. All right? Math is sometimes backwards. How do we know that this is approaching a vertical asymptote? Well, back in algebra, we said set the denominator equal to 0 because you know this has to happen. You can't have a 0 in the denominator. Well, how do we know you can't have a 0 in the denominator? Because of calculus. So what we are learning right here with our limits proves what we already know from our algebra class. So that's kind of what's happening here. We just accepted it back at that time. And now we're actually proving what's going down with all of that, with our vertical asymptotes here. All right? Okay. So stick with me here. We're going to do some examples. Let's do this one because I think we can do this one here on this same video before I switch over to something else. Here's example 2. We have the vertical lines x equals 1 and x equals 3 are vertical asymptotes. Use this figure to analyze that. We know that g of x is equal to x minus 2 over x minus 1 squared, x minus 3. Now tell me something that we know right now because of what we already talked about. What's that tell you? Yes, this means my vertical asymptote is going in the same direction. It's either both up or both down because this is squared. What's happening at my vertical asymptote x equals 3? Yes, opposite directions around that one. Good, 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 good. Okay, so we want to do the limit as x approaches 1 here of g of x. Now this tells me that we are going to analyze using our graph. Let me bring it up here. So right now we're getting the basics down, right? So we're looking at the graph, getting our basics. Don't worry, we'll do these analytically too. That's coming next. But for now, if I'm looking at 1, what is my graph doing as I approach 1 from both sides? Notice this is just a 1 by itself. I'm not going left and right on this. And I know I don't have to because of the square. See how this is all connecting? Yes, that's going to infinity. You guys nailed it. Great job. Now, what if I have the limit as x approaches 3 from the right? If I'm approaching from the right, what am I going toward? Good, that one's going to infinity. What if I approach from the left? Yeah, negative infinity. Exactly, you guys totally see that, right? If I'm approaching 3 from the left, then I'm going down here to negative infinity. All right, so looking at your graph, you can tell what we already know. Different characteristics, we can look at our characteristics, and that also helps us determine asymptotes and limits and what that looks like.